Today we are going to see the first chapter, number system. So in this chapter for the 9th standard CBSE board, they have discussed about the real numbers, representation of it on a number line, and the decimal form of it in this chapter. And before entering into the real numbers, let us recollect the numbers which we have already learnt in the earlier classes. In the childhood class, you would have learnt about the counting numbers, which I can put it on the number line. The counting numbers, it begins from 1, 2, 3, 4, 5, 6, 7, 8 and so on. These counting numbers, they are given a name, which is the collection of counting numbers. They are called as natural numbers, and the symbolic representation of these natural numbers is capital N. So the natural numbers are the numbers which begin from 1, 1, 2, 3 and so on. And now along with this collection of natural numbers or set of natural numbers, when we introduce 0, the number 0 into it, that collection of numbers is called as whole numbers. So you are going to introduce now the whole numbers. So with the natural numbers, when you introduce or when you add 0, the number 0 into the collection of natural numbers, this collection is called as whole numbers. And the collection of whole numbers is denoted by capital W. Now from these two collections, you can easily see that all the natural numbers are in the whole numbers collection. So all natural numbers are whole numbers, but the converse is not true. All whole numbers cannot be natural number. Why so? Because 0 is a whole number, but it is not a natural number. Understood? And after the introduction of whole numbers, if you introduce negative numbers to the left side of 0 on the number line, till now we have learnt about the collection of natural numbers and the whole numbers. And now along with these whole numbers, when you introduce the negative numbers, -1, -2, -3, -4 and so on, this collection of numbers is called as integers. And it is denoted by Z. So set of all collection of these numbers along with the whole numbers when you introduce the negative numbers or when you add negative numbers, this total collection represents integers. So the symbolic representation of these integers is denoted by capital Z. Now when we look into the collection of natural numbers, collection of whole numbers and collection of integers, we can easily see that all the whole numbers are integers. All the natural numbers are also integers. But the converse is not true. All the integers cannot be whole numbers. All the integers cannot be natural numbers. Why so? -1 is an integer, but it is not a whole number, as well as it is not a natural number. right? And then now we are going to enter into real numbers. So for the real numbers, in this collection of integers, when we look into the numbers in between two consecutive integers, say between 0 and 1, between 1 and 2, or between -1 and 0, between -2 to -1. So in between two consecutive numbers, you can find infinitely many numbers in between. So when we include all these numbers along with the integers, these numbers together, they are called as real numbers. So for the real numbers, we will have all the integers as well as we will be considering all the numbers which are in between two consecutive integers. So all these numbers together constitute real numbers. So when we consider all the numbers in between the integers as well as all the integers together, so this complete collection represents real numbers, and this real numbers collection is denoted by capital R. Now when we look into the natural numbers, whole numbers, integers, and now the real numbers, I can say all integers are real numbers. All whole numbers are real numbers. All natural numbers are real numbers. But the converse is not true. All real numbers are not integers. All real numbers are not whole numbers. All real numbers are not natural numbers. Why so? Suppose you take a number between 0 and 1. Say you have got a number. I can say there is a number between 0 and 1, say 0.5. 0.5 is not an integer. 0.5 is not an whole number. 0.5 is not a natural number. So all real numbers are not integers, are not whole numbers, are not natural numbers. This is how we can say about the numbers, right, on the number line. Suppose we consider, you would have learned about the set language, right? In the set language, we represent sets, right? Diagrammatic representation of sets we would have learned. Suppose I represent this set to be natural number set, diagrammatic representation, and I know this is a collection of natural number. N is a set of all collection of natural numbers, say 1, 2, 3, 4, 5, 6, 7, 8, and so on. When I, along with this set of all natural numbers, when I am including another number 0, so together all these numbers, they are called as whole numbers. And now 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on, they are called whole numbers. Now keeping this set of whole numbers in hand, you are adding some more numbers like negative numbers, -1, -2, -3, -4, -5, -6, -7 and so on. So when all the negative numbers are included in the set of whole numbers, it becomes set of integers. Now Along with this set of integers, when you introduce some more numbers, which are the numbers between two consecutive integers, so between 0 and 1, say 0.1, 0.2, 0.3, 0.111, 0.101, 0.25, and so on. So in between two consecutive integers, when you include all those numbers, the complete set is denoted by the real set, the real number set. So now you can see in this diagrammatic representation, real number set is the superset which contains integer set, whole number set, and the natural number set. So the integer set, whole number set, natural number set, they are all subsets for the real number set. Natural number set is a subset of whole numbers. It is a subset of integers also. Natural number set and the whole number sets are the two subsets for the integers. So for the real number set, which is the superset, there are three subsets: set of integers, set of whole numbers, set of natural numbers. For the set of integers, you have two subsets, which are set of natural numbers, set of whole numbers. For the set of whole numbers, you have a subset, which is the set of natural numbers. Subsets are nothing but the child sets. Supersets are can be considered as mother set. Okay. And now with this idea, we will enter into the definition of real numbers. Okay. So the real numbers, they can be of two categories. I can have the real numbers to be of two categories. One is rational numbers, the other is irrational numbers. The rational numbers and the irrational numbers together constitute real numbers. Rational numbers are denoted by the symbol capital Q. Irrational numbers are denoted by the symbol capital I suffix small r. So I can say that real numbers are going to be the union of the rational numbers and the irrational numbers. So when you combine the rational numbers and the irrational numbers, they together constitute real numbers. So let us see what is a rational number. Any number which is in the form of p by q, where q not equal to 0, p and q are integers and p and q do not have any common factor other than 1. Again I repeat, any number which is in the form p by q, where the denominator q not equal to 0, p and q are integers and p and q do not have any common factor other than 1. For example, suppose you are given a number, say 5. Is this 5 a rational number? If this has to be a rational number, you should be able to write this number 5 in the form of p by q. So I am going to write this 5 in the form of p by q, 5 by 1, where your q, what is your q here? Q is 1, which is not equal to 0, and these two are integers. P is 5, q is 1, and so both are not, they do not have any common factor other than 1, and they both are integers also. Suppose for another example, they ask you whether this number minus 27 is a rational number or not. So for any number to be rational, you should express them in the form of p by q, where q not equal to 0, where that p and q must be integers, and p and q should not have any common factor other than 1, which means p and q must be co-prime numbers. What do you mean by co-prime numbers? The GCD of the two numbers, if it is 1, those two numbers are called as co-prime numbers. And now suppose they are giving you a number, say minus 27, and they are asking you whether this is rational or not. As per the definition, I should write this number if I am able to express this number in the form of p by q, where q not equal to 0, and p and q are integers not having common factor other than 1, then such a number will be a rational number. So I will try to write this minus 27 in the form of p by q, where my q is 1, which is not equal to 0, and my p is minus 27, q is 1. So both p and q, they are integers. P is a negative integer, q is a positive integer. So they both are integers, and they do not have any common factors other than 1. That is, they are co-prime to each other. One more example. Suppose they are asking you whether 15 by 3 is a rational number or not. Right? Yes. So now the given number is already given in the form of p by q. What else I have to check? The first point is I have to check whether it is in the form of p by q. Yes, it is in the form of p by q. What is my q? Q is 3, which is not equal to 0. Second condition is satisfied. What about my p and q? P is 15, q is 3. Both are integers. Yes, correct. And what about their common factor? Right? So are they co-prime? No, there is a common factor for both 3 and 15. What is that? It is going to be 3. 3 is a common factor for both 3 and 15. So I have to remove the common factor. So I should remove it and write it as 5. And now this 5 can be written as 5 by 1. So whenever they give you any number in the form of p by q, try to write it in the simplified form, because p and q should not have any common factor other than 1. And now when I check with this 5 by 1, they are satisfying with p and q integers, q not equal to 0, as well as the third condition is p and q are not having any common factor other than 1. But when in the case of 15 and 3, they are having common factor other than 1. What is that factor? It was 3. You have to remove that common factor. Okay? Right. Now, the numbers which are not rational, the numbers which are not rational are called irrational numbers, which means if we are not able to satisfy all the three conditions, that is p by q, q not equal to 0, p and q are integers and they do not have any common factor other than 1. So in order to identify whether the given number is rational or irrational, you can consider the decimal form of the rational and the irrational numbers. So the decimal form of rational numbers. So quickly you can identify the given number is rational or irrational. So when you go for the decimal form, there are two decimal forms which will tell you that they are rational numbers. What are they? One is all the terminating decimals. All the terminating decimals are rational numbers. For example, 1 by 5 is a rational number. Why so? It is in the form of p by q, where q is 5 not equal to 0, p is 1 and q is 5, both are integers, and p and q are not having any common factor other than 1. So 1 by 5 is a rational number. So what is the decimal form of this 1 by 5? The decimal form of 1 by 5 is 0.2. So this is the decimal form of the 1 by 5. So it is a terminating decimal. Another example, 1 by 2. 1 by 2 is nothing but half, right? This is again in the form of p by q. Q is 2, which is not equal to 0. P is 1 and q is 2. So both are not having any common factor and both of them are integers. And this decimal form of 1 by 2 half is 0.5. Is it not terminating? Yes, it is terminating. So all the terminating decimals are rational numbers. So what about non-terminating decimals? Under the non-terminating decimals, there are two categories: non-terminating repeating decimals and non-terminating non-repeating decimals. So under this, all the non-terminating repeating is otherwise recurring. It is called as recurring decimals are rational numbers. Okay. For example, suppose you are given a number, say 1 by 3. So in this, is 1 by 3 a rational number? Yes, of course, 1 by 3 is a rational number, where q is 3, which is not equal to 0, p is 1, q is 3, both are integers, and 1 and 3 do not have any common factor other than 1. So 1 by 3 is the simplified form of p by q, which is a rational number. What is the decimal form of this? It is 0.3333. It goes on. Alright. So this is a non-terminating decimal and the digits are repeated. How many digits are repeated? There is only one digit, 3, which is keeping on repeated. So when you come across a non-terminating repeating decimal, this can be symbolically written as 0.3 bar, because your 3 is getting repeated. Are you getting this? Yeah. Suppose I am coming across a a non-terminating repeating decimal like 0.3145, 3145, 3145 and so on. So this is a non-terminating repeating decimals. How many decimal points are digits are getting repeated here? The digit 3, the digit 1, the digit 4 and the digit 5. So 3145, 3145, there are 4 digits which is getting repeated. So I can represent this as 0.3145 bar. When you put a bar here, which means that it keeps repeating. These 4 digits will keep on repeating. So in the decimal form, all the terminating decimals are rational numbers. All the non-terminating repeating decimals are rational numbers. What about the decimal form of irrational numbers? All the non-terminating non-repeating means what?